Welcome to Mona Tutorials. In this session we will be looking at a 10-speed time-lapse of the hard surface modelling stage of the Cyberpunk car. At the start of each section I will go over some of the details of the creation process, from general considerations, common Blender tools, and the modifiers I use to create the hard surface high polygon asset. Let's jump in. The first thing to create is a high polygon asset to create an optimized asset from. Here is an example of the end result. This could be made in any way, such as digital sculpting, AI asset creation, or in my case, hard surface modeling. As you can see, the poly count is significant, which is not ideal for an optimized experience such as WebGL, standalone VR or XR, or mobile. We will need to optimize the asset afterwards, but for now, that doesn't matter. I start off by adding reference images to work with. This could be your own drawing or reference that you pulled in from elsewhere. There are various approaches to making assets. Some go with a primary, then secondary, and finally tertiary approach by making all of the basic shapes first to get an overall feel of the asset, whereas some get into the details straight away. Both have pros and cons, of course. In my case, I feel that the primary to tertiary approach is more efficient, but doesn't get you the type of feedback that keeps the motivation up. You can combat this by trusting the process, but sometimes this is very hard if you are new to asset creation, and to be honest, even if you aren't. The issue with getting into detail early is that you will find that you will most likely change the asset later, as you find better ways to approach elements, or simply find a different result you like elsewhere on the asset that means you want to update, or even completely remove, previous elements, which wastes a lot of time. You learn a lot during this process, so it may balance out. With experience, you start to see potential issues with ideas you might have earlier in the process, or simply better or faster ways to create the same result. Every asset you create opens up a lot of tools to improve your workflow. One thing I keep in the back of my mind is that optimization is as important as the result, and therefore balance the details accordingly. If I wasn't aiming for mobile or standalone VR or XR, then this would be less important. You should keep potential optimizations in mind during the entire process to help design the asset as you go, such as duplicate or mirrored asset creation, to save time and resources. You could consider what elements can use overlapping UVs to increase the use of UV space on the texture, and what techniques would improve the result. If creating a GLB, there may be further steps you need to take in order to have this approach work in engines such as Unity. This will be covered in a later tutorial. Keeping the low poly target in mind allows you to consider if the detail in the high poly would not transfer well to a low polygon result. It's usually pretty easy to go with a different design that is equally good, just more optimized. Over time you start to understand what detail is difficult to bake into a normal texture. Texture resolution is a key element to this, but also some detail is just really hard to bake well. This can be worked around with redesign, but some creation workarounds can also help. Some elements are actually easier or better to add directly into the normal map during the texturing stage. This is very much case by case and comes down to the type of detail needed. I decided to have the windows be tinted in order to not have to worry about creating an interior and be more optimized overall. If I wanted a transparent window though, I can either use one material for everything with transparency, or two materials. One that is opaque, and a smaller material that has the transparency. Depending on your use of transparency, you may need to split the transparent elements into its own material, as GLBs seem to have some weird issues with transparency versus opaque areas on the same asset material. Most of this asset was made using very few tools in Blender. Apart from the basic position, rotation, and scale, I use the following. Delete. The main thing with this one is the difference between delete and dissolve. I will use dissolve edge a lot to clean up unwanted edges on an asset, with delete being used for actual faces when needed. Another useful tool, although more so for the low poly, is limited dissolve, which attempts to clean up all the edges that are not required based on angle. Extrude. This gets me started pretty quick with basic overall shapes. Depending on the extrusion needed, I will usually switch between extrude region, extrude normals, and extrude individual. Next up we have the new edge or face from vertices. This is the big one once I get into the middle or detail stages. I also add the Mesh F2 add-on into Blender, as this offers some extra functionality such as quad from vertex and quad from edge. I use this all the time, from adding quads quickly from 3 vertices that are available to closing or joining loops. Next up we have the loop cut or slide. With the primary shape made, I use this one a lot to add in loops and adjust their position afterwards to start filling out the mid details. Having clean loops allows this tool to be utilized faster and easier throughout the entire process. So if possible, I like to keep edges organized for as long as possible. With a high poly asset, this is easier to do as the poly count doesn't matter, but this is more difficult on low poly assets. Then we have the knife. The knife is great for adding edges where you need them, after the basic shapes have been defined. I personally don't use bisect that often, but it can be useful when you need to cut across an entire asset. Next we have the inset and bevel tools. I use these significantly less than the previous tools, but they can be very useful when needed. Another super useful add-on found within the default installation of Blender is the Loop Tools add-on. This one allows you to set selected edges or vertices to a circle, among other shapes. I pretty much only use the circle one. I will occasionally use the Mark or Unmark Sharp tool. I sometimes use this to visualize edges better. This approach can be used in different ways, but I ended up using edge weights instead, with the subdivision modifier, to get exactly the bevels I was after in the high poly result. As the entire process does take some time, I'll be adding commentary at the start of each section of the video. You can either continue watching at 10 speed with some music, or jump ahead to the next marker. With the primary pass done, I can start looking at the secondary and tertiary details, and for that we need to use some modifiers. Modifiers are tools you can apply to your model to do a ton of useful things. In this case, I used 3: mirror, bevel, and subdivision. I use the mirror modifier quite often with many of my assets, at least to start, as most things start symmetrical. That said, a common approach to more interesting assets is to make them asymmetrical by the end, so how long you keep the asset mirrored depends on what you are making. In this case though, I could keep the asset mirrored for most of the process, at least in the hard surface modeling. The bevel modifier, with the subdivision modifier, is what allows me to speed up the hard surface process by adding extra bevels, as needed, to the low poly asset, with clean results in the high poly asset, basically saving a ton of time. In the bevel modifier, set the limit method to weight. This way, you can define exactly which edges have a sharp bevel on them by selecting an edge, select Edge Bevel Weight with right-click, and then drag the mouse to adjust the amount. Finally, we add the Subdivision modifier. This is where the high polygons kick in, resulting in super smooth result. If your computer starts to lag due to the subdivision poly count, take down the subdivisions as this will help speed up the process. You can occasionally increase the subdivisions to see if the asset is looking as expected. Depending on how sharp you need to make certain edges, it was common to need to add more edges in some areas to clean up or sharpen the detail. In some of the areas, once I get to the detail section, I added extra loops so that the edges are more crisp. This approach applies to various results to end up with the result you want. If you decide to use the original mesh for your low poly model rather than retopologize from scratch, you would need to clean up these extra edges manually, as they will add a lot of polygons to the result for zero benefit.
That's it for the commentary on this video, apart from the summary at the end. The main thing to note is that due to the resulting poly count of this asset, we will need to do an optimization pass to create an asset to bake this high polygon detail onto. We will be looking at that in the next video.
When I turn off optimal display on the subdivision modifier, I can see how many polygons there are on the asset. About 770,000 triangles. This is not recommended for just a car in nearly any ecosystem, unless you count high-end gaming desktop experiences. Therefore, we need to do an optimization pass. We'll be looking at that in the next video. And with all that, we have the result of our final hard surface, high polygon asset. With that, we can start looking at the optimization pass, which is what we'll be doing in the next video. Thanks for watching, and happy building!